Welcome back to Cat's Cast, the bi-weekly podcast featuring local interviews, arts and culture, history, and sustainability in the Catskill Mountains and Hudson Valley. Confronted by the deleterious effects of modern consumerism and the fossil fuels required not only for the manufacture of all those products, but for the transport of raw materials and finished goods round and round the globe, a tour of Hanford Mills in East Meredith, New York, offers stark alternatives: local goods, community, sustainable production. Many of the goals we're striving for today were, in many ways, achieved more than a century ago. We met with Executive Director Liz Callahan, Education Coordinator Luke Murphy, and Mill Operations Manager Robert Dianich, who illustrated the renewable power of water to process locally sourced materials into locally consumed products.
Hanford Mills was built as a seasonal sawmill in 1846, so we're celebrating our 175th anniversary of the main sawmill building this year. I am Liz Callahan. I'm the Executive Director of Hanford Mills Museum in East Meredith, and East Meredith is a hamlet that's kind of located between Delhi, Stamford, and Oneonta in the foothills of the Catskills. The mill was kind of sited where a couple of creeks come together in a bit of a valley, so it's a good source of water for a sawmill. That's how they kind of decided to build a mill here. And the mill grew over the course of the 19th century and the early 20th century into a sawmill that was a full-time operation with a woodworking shop that processed woods into a variety of different things, and a gristmill that served the local agricultural community. The mill was in operation until the 1960s as a business. The milling operations really wound down slowly and steadily after World War II. The business ended with kind of the hardware store kind of supplying local needs. We are an example of the mill businesses that served every little hamlet and town and crossroads throughout the Catskills, really throughout rural New York, and in some form or fashion throughout rural America for, certainly the 19th and well into the 20th century.
The Hanford Mills Museum comprises 15 historic buildings on its 70-acre property. Liz brought us right to the sawmill, where we met up with Luke and Robert for a live demonstration.
My name is Robert Dianich. I'm Mill Operations Manager. Today we're cutting hemlock, and this one log here is a 10-foot piece of hemlock. We're aiming to get a 12 by 12 square beam, and then I can downsize it from there to get the timber that we are in search of, we'll say.
Rob is getting the most he can out of each cut, and then what gets done with the bark, the sawdust, we try to align it with what would have happened historically, but to have as little waste as possible, too. Some of it ends up as boiler wood for a steam power plant, some of the slab and the waste. The sawdust we use at ice harvest when packing the ice house. That insulates the ice. And then if we have leftover sawdust, some local farmers might use it for animal bedding, things like that. People are even taking it for things like composting toilets. Traditionally, there were tanneries in this area that would have used hemlock bark for tanning processes, things like that. We are not doing any tanning these days, though. The Hanfords did not either.
Hi, my name's Luke Murphy. I'm the Education Coordinator here at Hanford Mills. There's a water wheel below our feet. Where Rob is standing, he's got a wheel that opens up the gates. The water goes over the wheel. The wheel turns a belt and pulley system downstairs. Right next to the saw there's a big belt. That belt turns the saw. Downstairs again, there's a cable system that will bring the carriage back and forth, and it'll cut pieces of the log into pieces we can use. The wider open the gates are, the more water, the faster the machines go, or more power to them.
Rob opens the gate, allowing water to pass through the mill. It turns a giant water wheel below a similarly giant saw blade, which cuts easily and repeatedly through a 10-foot length of timber. The gate that controls the flow of water, and subsequently the power of the saw, is holding back the water content of a creek-fed pond adjacent to the building.
The pond was hand dug at the same time the mill was built, so 1846 approximately. It's about 1 million gallons capacity. Right here is the deepest where we're standing. It's about 12 to 14 feet, depending on the level of sediment down there. And it kind of gently slopes up so it's more shallow on the far side. It's a very environmentally friendly way to power things. The pond is fed by a creek. It's stored here. When it's a little bit full, as it is now, given the rain we've had, it goes over what's called a spillway and goes right back into the creek, more or less. We also use the water for our water wheel, which is beneath our feet, more or less. And when the water comes over the water wheel, it goes right back out to the creek. We've always been a water-powered site. For much of our history, we've used the pond directly. Other times, we've used water in wells to power our steam engines. The water has been used to power turbines as well as dynamos, which create electricity. And the setup we have now has been more or less consistent since the 1920s.
To see and hear what was happening below the sawmill, Luke and Liz brought us down to the heart of the building, where the water wheel and its web of belts and pulleys bring the building and its tools to life. You can see, hear, and on a guided tour, feel that water power as it rumbles everything around you.
The water wheel is the primary source of power. We started off in the 1840s with what would look like a paddle wheel on the side of a steamship. In 1926, they brought in this particular wheel, which is an overshot wheel. It's got buckets as opposed to just slats that you see on a paddle wheel. The water comes in through those gates, through those dark brown there. You can see the water trickling in. Fills those buckets. Once the weight of the water has reached a certain point, it makes the wheel turn, which will then turn that large pulley right there, which is connected to this line shaft, and that's how it transmits its power. So from the water wheel to that large belt and pulley, and then to all these other individual belts and pulleys. There's no switches down here, so we'll physically call up to Rob or Kevin, whoever's at the wheel. We'll say wheel on. If you folks would like to join me, you can do that on the count of 3. 1, 2, 3. Wheel on!
Water pours in, buckets fill, and the wheel begins to move. It activates a 360-degree Rube Goldberg array of gears, pulleys, and belts. Standing there in the middle of it all, you are inside the machine itself, and the history and energy of the mill washes over you like the water that's powered it for centuries.
The Hanfords also used water turbines a lot, especially in the later 1800s and until they started integrating steam power. Water turbines are like little mini horizontal water wheels. You might see what looks like, I'd describe it as a sewer pipe, but a big metal pipe. It's water that's been diverted around the sawmill to the turbine, which we're looking right down on. And all you see is a metal casing. But inside that metal casing, imagine a water wheel, not a very big one, flipped on its side. And as the water comes through that big metal pipe, and this is where the pressure, the amount of water in the pond and the angle of the pipe, that head pressure really matters, that water wheel begins to turn, and then this begins to turn the gears and the pulleys connected on the horizontal shaft here. This particular turbine turned the millstone mill, operated this scroll saw, and operated the edging machine up in the sawmill. There were a couple of different turbines operating in the mill and a couple of different turbine pits. Turbine power is isolated, very efficient in that respect. You're not sending power throughout the mill like our water wheel does. And they could use it in a very kind of strategic way for different machines and operations. Think about the math and science and engineering involved in the power transfer of something working at the right speed to do this work from that water wheel through the belts and shafts and pulleys, and that has to do with the size of the pulleys used in between and so many other things. And that was with a pencil and a piece of paper. And that was with people being able to listen and hear and pay attention to how things sounded. So simple, yet really intuitive, and took a lot of science and understanding of even the products you were working with and the type of wood you were using at that point.
Operating at a time when Delaware County dairy cows outnumbered Delaware County people, Hanford Mills processed farm feeds and fabricated containers for dairy products. More on that after this short break. CatsCast is supported by WIOX Community Radio, live and local in the Catskills, reflective, responsive, and supportive at 91.3 FM, MTC Cable Channel 20, WIOXradio.org, and with any smartphone radio app. Alexa, play WIOX. And by the Central Catskills Chamber of Commerce, providing services to businesses, community organizations, and local governments in the Central Catskills region. Hanford Mills is a member. How about you? Sign on at centralcatskills.org.
Many people are probably aware how significant dairy was to Delaware County in the late 1800s and early 1900s. The level of production, the quality of Delaware County dairy products was second to none.
At one point in time, in the 1880s was around the peak, Delaware County was close to, if not the dairy producing center of the country. There were about 5,000 farms with a combined total of about 50,000 cows. And that's not to mention all the chickens, goats, pigs. There were more cows than people in the county. Cows eat a lot, they need a lot of feed. And to make feed from corn, from wheat, from grains can be time consuming. So the Hanfords invested in a gristmill, which creates animal feed from grains or corn, what have you. 800 to 1,000 pounds of feed an hour is what it could do. I'm not sure that they ran it for a full hour, but that's the level of output it could do.
Until local farmers could transport their milk to market in liquid form, and that meant better transportation, refrigerated train cars, things like that. Most of the dairy products that left Delaware County were in the form of butter and cheese.
Coopers supplied firkins, or small barrels, to ship all that butter. And Hanford Mills turned out tens of thousands of lids for those barrels. Those lids are quickly crafted in two side-by-side water-powered machines, creating a tongue and groove joint and a round beveled edge.
We start off with two blank pieces of wood. We put them in this machine, which is called our matching machine. Rob's turning the water on. Once that gets going, what we'll do is we'll do a tongue and groove joint. We put our blades in here and we activate the pulley.
These firkins were the types of containers, tubs, the butter was shipped in. They were recycled or reused. A Cooper made these. That would be a longer, more time-intensive, more expensive process. So they were reused, but the tub covers were usually broken off and used as kindling. And that's why the Hanfords were making thousands and thousands of them, because this was not expected to be reused.
No.
And just a couple of decades after Edison's invention of the light bulb, the Hanfords not only sold those bulbs to their customers, they provided the power with which to light them.
Another form of water-powered equipment, and this is a very early form of hydroelectric power. This is called a dynamo. This was what was used to power lights in the mill beginning in the 1890s. And as you can see in the back, there is a pulley, which could be attached to a belt, which connects to either a turbine or the water wheel. As that turns, the inner components of the dynamo create an electric current, a direct current. Since it's DC, the voltage isn't as high as it is modern, but it was enough to go about a mile out from the mill. So folks within about a mile radius would have had electricity. They'd buy their bulbs at Hanford Mills, and to my knowledge, they didn't charge you after that. You could use it as much as you wanted, as long as you bought your bulbs here. So this was not their bread and butter. This was a side service. Hanford's also for free put up some streetlights in East Meredith.
So many of the processes that happened here are very invisible to people today in their daily lives. Where your wood and your grains come, where your ice comes from the ice cube maker that you put your cup under. How we talk about a process really show from logs to lumber to crate, from corn to cornmeal, from water in the pond to a block of ice to ice cream. All of these processes are not clear in our daily lives. We just see the finished product and often don't give thought to where that finished product came from. So the idea that people can follow a process, you can look around and see the trees very much like these logs. Think about the logs being harvested just 10 miles away. And think about them going through the sawmill with water that's returned to the creek. And then the products being used maybe on one of these buildings or a neighboring farm, or a visitor buys a crate and uses it for something in their home. It's all very local and it's all very tangible. That's a layer of the onion. Then we start to encourage people to peel about other things in their lives. How do we challenge our visitors to think about, okay, you saw this process from beginning to end. Think about the other processes in your life that you might take for granted and what goes into them today or historically. Then we have a whole other layer where we're trying to be relevant today, and that is talking about the resources that are part of these processes. We really try to emphasize to people and help them kind of connect that we're using renewable power here. The water's just being borrowed from Courtright Creek, held in our mill pond, goes over the water wheel to generate that power, and it's returned to Courtright Creek. Today in our lives, so much of what we use takes a lot of energy. How are we generating that energy? What resources are being used? Are we generating it in a sustainable or renewable way? And I think more and more every day it becomes clear to many of us that that has to be a question we ask and something we weigh into. And the other resources we use, whether it's food or fabric for clothing, materials for houses, or the things we use on a daily basis, how were they produced? What demands are they putting on the earth in their production, or other people, or how are they being used, and then how are they being disposed of? Following that cycle and really encouraging people to think about that as much as possible as we face some big questions as a world about resources. So we hope to be historically relevant with these very tangible things that people can see happen here. But we also hope to pose some really challenging questions and help people to think about how this is relevant in their lives today, because I think it really is.
For more information and to schedule a tour of your own, visit hanfordmills.org. CatsCast is a production of Silver Hollow Audio. Please be sure to subscribe wherever podcasts are found for free and automatic delivery every 2 weeks. You can find us on Instagram at CatsCast. Thanks again to our local sponsors and to you, our listeners, for your contributions to the show. If you'd like to contribute, just click support at catscast.com. Until next time, I'm Brett Barry. Thanks for listening.